Okay, welcome to day 3 of probability. We're going to be covering combinations today. Now there are some similarities between combinations and permutations, but by the end of this, hopefully you have it sorted out. If not, like always, please ask me questions tomorrow in class if you have any. Write them down on your paper. Speaking of paper, make sure you have a pen and paper. It'd be kind of hard to write anything down without the pen. Okay, and just write it down on your arm. Chances are when you shower in the morning it washes off, so make sure you have a pen and paper, please. Take good notes. Answer the questions at the end. Alright, let's start this off with vocabulary. We only have one word today, and it is combination. Combination is a selection of objects in which the order is not important. Okay, now take for example what we did yesterday with permutations. We had the word cat. And we found out there were 6 permutations of that. 6 different ways that you could organize the letters in cat. Now with combinations, order is not important, so you can arrange them however you want. There's still only one combination if you're using all 3 letters. Okay? So hopefully that'll kind of start to give you an idea as to how this is different. But let's go ahead and do an example. We want to find out how many 2-letter combinations there are from the list A, B, C, and D. So you could sit here and you could say, okay, well there's AB, there's AC, AD, BA, BC, BD, CA, CB, CD, DA, DB, and DC. So those are all our different 2-letter combinations. But like I said, order is not important. I'm even going to underline that. Order is not important. So that means that here we have duplicates. A, B, and BA, we're talking about combinations, so they're the same thing. So we get rid of one of them. Same here. BC and CB, and you go ahead and you find all the rest that are duplicates. And that leaves you with 6 total combinations, which would be your answer. Now there is an easier way to figure this out, because trust me, if you had a list of say 10 different objects, you don't want to have to draw out this list and go through, find the duplicates and cross them out. You'd never get through problems quickly doing that. So luckily they have a combination formula. You use this to find the number of possible combinations that exist for a given problem. This is different from permutations because the order does not matter for combinations. I'm going to drill that into your heads. And to find the number of combinations of n objects taken r at a time, as long as r is greater than n, we use the following formula. Okay, now this is, I know, looks a little, intimidating, but trust me, it's not. This, you're going to find a key for this on your calculator, and I will show you how to do that when I see you in class tomorrow. But for now, the main thing you need to concern yourself with is n is the same thing as the total number of choices, we'll call it choices, objects, we'll use that interchangeably, and r is the number being used at a time. So hopefully I put that in simple enough terms that you kind of get the idea as to how this works. Alright, so you've got your formula here. We're going to go ahead and just kind of move on to the next problem so you can see it in use, and hopefully you'll understand it a little bit better. So you're at Paisan's and you want to order a pizza. You can choose 3 toppings from a list of 12. How many possible combinations of toppings are possible? Well, we've got 12 total combinations, because remember, we've got this formula that we can use. N, C, R, and that's all over n minus r. And that whole thing, once you do that, you find the permutation of that and multiply it by the permutation of r. So we've got 12. This C means combination. R is how many we can choose at a time, so we're doing 3 at a time. So that's the same as 12 permutation over 12 minus 3, and that whole thing, once we figure that out, we do the permutation of that times the permutation of just 3. Okay, now remember I said it would get easier. I want you to start with the bottom. 12 minus 3 is 9. So we have the permutation of 9 times the permutation of 3. And then on top, I want you to start writing out the permutation. But when you get to 9, because that's what's down here first, I want you to stop and just leave it as the permutation of 9. Okay, what that does is that allows you, it says, okay, well, I've got a permutation of 9 here and a permutation of 9 here, so I can just cross those off, because the permutation of 9 divided by itself would just be 1, so we don't even show it. So what that leaves you with is 12 times 11 times 10 over 3 times 2 times 1, because that's the permutation of 3. Now, you'll have calculators, so I won't expect you to do this, but 12 times 11 times 10 is 1320 over 3 times 2 times 1 is 6. So simplify that and you get 220. So there are 220 different combinations of toppings. Okay, so hopefully you kind of have an idea as to how it works now. So, just to recap, we write it as such, and to find the number of combinations, you use your combination formula from the previous slide. So let's clean that up a little bit. We did 12, just like it says. Put it over that. 12 minus 3 times 3. And then we stopped, because we found out that was 9 right there. And we did 12 times 11 times 10 times 9 and stopped when we got to 9 because these two matched up. Since they match up, we can get rid of them, leaving you with 1320 over 3 times 2 times 1, which is 1320 over 6, which simplifies to 220. So that matches up with our answer of 220 different combinations of toppings. Now, there is kind of another way of doing this. You could say, I'm just going to write my permutation on top. 12 times 11 times 10 times 9 times 8. You don't have to keep going. I'm just doing this to illustrate for you the way of doing it. And this is why I like starting on the bottom here, because I could say, okay, now on the bottom I have the permutation of 3 times 2 times 1. Now when you're doing combination like this, you can't use any more of the top than you use on the bottom, meaning I've got 1, 2, 3 numbers on the bottom, so I use the first 3 numbers on top. We can get rid of all that then. So that you can see that would end up giving us the same as what we have down here. So it's just kind of a shorter way of doing it. That's the way that I personally do it, but the formula is the more correct way of doing it and helps you understand it. So I would learn both and then just go with whichever one you prefer. Alright, yo-yo. What does that mean? You're on your own. Okay. So time to show me what you can do. Find the number of combinations of 2 letters from the list A, B, C, D, E, and F. And then suppose we take our earlier pizza example. If you could only choose 2 toppings out of the 12 topping choices, how many possible combinations of toppings are there? So this is where I want you to kind of pause the video, take a few minutes, try and do it on your own, and then come back and we'll work through it. Okay, so let's go ahead and figure this out. We've got 6 letters, A, B, C, D, E, and F, and we want to find 2-letter combinations. So doing this the long way, I'll do this one the long way and the other one the shorter way. We have the permutation of 6 over 6 minus 2, permutation times 2. So that would give us 6 times 5, and we got to figure out where to stop. So 6 minus 2, that's a permutation of 4. So we're going to stop right here, because now we can cross that off and that off, which will leave us with 6 times 5 over 2 times 1, which is 30 over 2, which is 15, which would be 15 combinations of 2 letters. Now the shorter way of doing it, still write it the same, this initial 12C, and now we're doing 2 toppings. So I could say, well, on top I'm going to start with 12, but on the bottom I'm only doing 2 times 1, because it's the same as the permutation of 2. And on top, since I've only got 2 numbers down here, I have to stop after 11. So 2 times 11 is 132. 2 times 1 is 2. So now we only have 66 different combinations of toppings. Okay, so hopefully you got that same answer. Alright, now to wrap things up, I'd just like you to answer these two questions. How are combinations different from permutations? And is calling the sequence of numbers that you get into your lockers, that you use to get into your lockers, a locker combination, inappropriately named, at least from a mathematical standpoint? In other words, do you think calling your combination to get in your locker a combination is accurate? So just go ahead, write those two answers down on your paper, and I will check them the next time that I see you. And hopefully you've enjoyed these so far. We've got one more to go, and we will see you soon. Take care.